Hello, my name is Mohammad Zare and I'm a PhD candidate at Shahid Beheshti University in Iran. I'm happy to provide a brief overview of my recent research titled Enhancing Magnetic Impedance Response with Anisotropic Surface Charge Accumulation enabled by electroresponse fiber coating and co-based ribbon. A cobalt-based ribbon is a conductive and flexible for magnetic material. Due to its high susceptibility to magnetic fields, it's widely used in magnetic sensor applications. This study is the first to examine how nanofibers impact magnetic impedance sensor ability. We choose PVA-TiO2 composite fibers for it. These fibers are non-magnetic and have higher dielectric properties. We attached ribbon to the electrospanning collector. Polymer fibers, when connected to positive voltage contacts, fly towards the collector and after coating on the ribbon surface, trap some charge, resulting in charge accumulation. These images show electrospinning with varying durations to achieve different fiber coating densities on the ribbon surface. Uh, the magnetoimpedance effect is an effective mechanism for designing magnetic sensors. This mechanism involves passing an AC current with a megahertz frequency through the sensor material. The sensor impedance values vary depending on the sorry, depending on the frequency. This impedance changes at a constant frequency with the application of a magnetic field and allows the determination of the magnitude of the magnetic field. The change in impedance is due to the change in skin depth. Increasing the magnetic field causes the skin depth increases, resulting in a decrease in impedance. By assembling several simple devices and controlling them with a computer, it became possible to record impedance change in real and imaginary parts separately. Ribbons are put into a solenoid along its axis to control the magnetic field. The percentage change in impedance reflects the MI response. Um, this plot shows the MI response of samples measured by sweeping the field at the various frequencies. Every sample, such as the Bayer ribbon, has double peaks at their maximum. Um, Plotting the maximum MI response of samples at different frequencies shows that impedance change peak around 10 MHz. The comparison of the samples' MI responses at this frequency indicated that increasing fiber density had an increasing trend until it reached the optimal density, beyond which point it has a negative effect. Electroresponse fibers had the highest response over 15 minutes and were around 30% density. Magnifying the maximum points of their double peaks shows that they are actually still similar to the Bayer ribbon. Sensitivity change follow a similar trend to MI responses. Sensitivity, the amount of impedance change caused by magnetic field change, is a suitable measure for comparing magnetic susceptibility. We use polymer fibers with high dielectric properties that can hold a huge amount of charge. In addition, charge accumulation occurs on the interface of TiO2 particles and dielectric, increasing the total charge and it causes increasing the total charge. On the one hand, the presence of this positive charge above ribbon surface results in, in the accumulation of negative charges in it. The presence of the charge together produces an electric field that is perpendicular to the ribbon surface. This electric field attracts conduction electrons to the ribbon's outer surfaces and reducing skin depth and also increasing impedance. As fiber density increasing, positive and negative charge accumulation increasing. High density of electrons at the interface acts as a shield against the electric field and avoided from entering from more penetration at it. As a result, increasing fiber density not only improves but also reduces the MI response. As you can see in the slide, these results are printed in a paper. Also, I must mention that we explored for the first time the usage of electroresponse fibers for MI sensors. So far, the impact of irregular fibers has been studied. Fibers which were used reduced to ordinary electrospinning, also known as far-field electrospinning. In the next study, we reduced the flight distance of polymer fibers to the collector with a few modifications to the electrospinning setup. This method, known as near-field electrospinning, is capable of producing parallel fibers. The ribbon was now fixed horizontally and vertically to the collector. The fibers actually are electroresponse transverse and longitudinal on ribbons. Now it was possible for us to investigate the effects of anisotropic charge accumulation on ribbons. Because all electrospinning conditions were alike for both new samples, so we obtained the same density, but with the difference in the direction of anisotropy. So, as you can see, these plots display a single peak, which indicating the maximum MI response of the ribbon with longitudinal fibers, while the ribbon with fibers parallel in width still has double peaks. I'm sorry again. Separating the real and imaginary impedance parts and analyzing them separately confirmed the single peaked response in both. Longitudinal anisotropy had two effects. First, an increase, and the second, a single peak in the maximum MI response. Sensitivity indicates that the sample has an increased magnetic susceptibility. The important outcome of this single peaking is that the ability to use this sensor for observing smaller fields. Anisotropy in charge accumulation actually creates an electric field which is perpendicular to the surface. The presence of this field, as well as polar links between TiO2 particles and the hydroxyl group of PBA polymer, help in the electric polarization of fibers. An 80 MHz current passing through the ribbon produces an AC magnetic field. That this field interacts with the electric field, resulting in the induction of a magnetic field along the fibers. The induced magnetic field changes the orientation of the ribbon. The ribbon surfaces magnetic moments. Aligned magnetic moments along the ribbon axis change the direction of the easy axis in the same direction as the ribbon length. And this phenomena resulted to the single peak in the maximum point of MI response. So, all of the mentioned results in the second part of my presentation were published in this article that you can see in the slide, and you can, for more information, you can go to it and use it. And in the end, I want to thank you from all of you and appreciate your time spent on this presentation. Goodbye and have a good day.